So, as a corollary we can say that the ground state spin of an odd A nucleus must be equal to the J of the odd neutron or proton. So, this point again can be discussed in the later chapters afterwards. Okay, इसको कर लो. Okay, what is a corollary? हो गया ये बंद?
It is a subsequent result that we get from a theorem or a solution of.
Corollary का ये मतलब होता है?
What?
ये are you sure this is the meaning of a corollary?
Mathematically, yes.
It is the subsequent result of a.
Of a theorem, like if I were to solve a theorem and I have got a result, but I can derive more results from that result.
It's like an induced result. It's not a direct result, है ना? It's not a calculated proof. Like theorem का proof होता है, corollary का proof नहीं होता.
Yeah, this is what you just realize.
Yeah, you deduce from this, right? Yeah. Because I remember when we were in school, we used to have a Australian teacher, and she used to say, "Now I am going to tell you a corollary." And there were so many corollaries and theorems we used to study. But the theorems we used to prove them. The corollaries we had to accept. So, yeah. स्टार्ट कर लो. अब एक और चीज़ पढ़ते हैं. यहाँ पे हम स्पिन को ख़त्म करते हैं, पैरिटी की बात करते हैं. ओके. So we have like 10 minutes, right? Okay. Okay. Now, just as we discussed the spin property of the nucleus, we also need to understand the parity of nuclear states. So, parity is another concept, and are you familiar with parity?
Maybe it's a change, when we change it, it doesn't.
Huh?
Maybe it's a change, or the whole sign change.
Okay. Any ideas? Okay, parity is again we have a small explanation for this on page 37, like I am referring to that. It's an operation, right, that causes a reflection mathematically, right? Okay, we can define it as that, but then later on we will try to understand it, how we can relate it to the nucleus. So, the parity operation causes a reflection of all of the coordinates through the origin. So, for example, you can reflect a vector r2 minus r. So, if you have a coordinate system and you draw a vector r, when it reflects you get minus r. It is just like a mirror operation, right. Okay. In Cartesian coordinates, this means x will be reflected to minus x, right, y will be reflected to minus y, and z will be reflected to minus z. Now, in this case, if the system remains unchanged by the parity operation, then we expect none of the observable properties to change, right, as a result of the reflection. So, for example, if VR is equal to V minus R, then the function psi R squared will be equal to psi minus R squared, right. So, this is an example, and if this is the case, then we can say that psi minus R is equal to plus minus psi R. That is, the parity operation has either of two effects. On a wave function. So, the case psi minus R is equal to plus psi R is known as positive or even parity, and the case psi minus R is equal to minus psi R is negative or odd parity. Okay, so I will explain this. So far you understand this, you know, R is a vector, it is reflecting like a mirror and you get minus R. If we speak in terms of Cartesian coordinates, x will be reflected to minus x, y will be reflected to minus y, z will be reflected to minus z. Now we try to bring this concept and relate it to the properties of a system, of a quantum mechanical system. Again, the word quantum should not be scary, okay, because we do know that the nucleus is a quantum mechanical system, right. There are certain properties of the nucleus that can be explained as classical, you know, with the help of classical physics, and there are certain properties in which we do have to keep in mind the quantum mechanical or quantum physical concepts. So, for example, in that case, if we have a property of the system which is VR, and after the parity operation it still remains the same, then there is a possibility that the wave function in this case can be written as is written there, right. So, psi normally is a symbol that is used to represent the wave function, and the wave function is used to describe a quantum mechanical system. It can be a particle, it can be anything. Okay, this is just a function, wo to later on we can play with it and find different things, right. Okay, so in this case, when we say this, we say that the parity operation has either of two effects. There are two possibilities, right. One possibility is that when the parity operation is applied, the value remains the same. This is known as positive or even parity, okay. So, sometimes you will see positive or sometimes you will see even, it is the same thing, right. And the second scenario is that the sign changes when you apply the parity operation. If the sign changes, then this is known as negative or odd parity. बना लिया आपने? Okay. So, this was an explanation of parity from chapter number 2, page number 37. Again, I am just using that as a reference to explain some symbols and some concepts. Now, I will like to come back to page 71, which is chapter 3. Ghabra to nahi na, we are jumping back and forth, it's fine, hai na? Because we are just using those concepts and equations time to time, and whenever we use them, I try to explain them before we come to the actual topic. Okay, so page 71. We explained what parity was, and now we know we are going to talk about the nucleon again and the nucleus again. So that's what we are doing. Okay? So if we know the wave function of every nucleon, we could determine the nuclear parity by multiplying together the parities of each of the A nucleons. Okay? Again, we know that the nucleus is composed of the nucleons. The total number of nucleons inside the nucleus is capital A. Now, if we know the parity of these nucleons, then the parity of the nucleus will be equal to the product of the parities of all these nucleons. Okay? And the end result would be either the parity